Every minute, 2 truckloads of plastic dump into the ocean, over 20 million tons annually, and 80% of it is plastic that survives underwater for centuries. American engineers refuse to accept this as permanent. They built a system that lets the ocean clean itself. The scale of the crisis: between 75 and 199 million tons of plastic currently float in or sit on the ocean floor. Another 11 to 15 million tons enter annually, the equivalent of dumping a garbage truck into the sea every 60 seconds, non-stop, forever. But here's the hidden nightmare. 99.9% of ocean plastic doesn't float in visible patches. It sinks to the seabed, where it breaks down into microplastics, particles smaller than grains of sand that enter the marine food chain. These fragments have been found in human blood, placentas, and the air we breathe. Turtles trapped in fishing nets, fish sheltering in discarded bottles, crabs living inside plastic containers. This isn't just environmental damage. It's a systemic poisoning of the entire ocean ecosystem, affecting 700+ marine species. Traditional cleanup methods failed. You can't send boats to manually collect trash across millions of square kilometers. You can't use fishing nets without catching marine life. The ocean is too vast, too unpredictable, and trash doesn't stay in one place. American engineers realized something critical. Instead of fighting the ocean, work with it. System 003, the ocean's self-cleaning mechanism. System 003 is a massive U-shaped floating barrier stretching 2.2 kilometers long, longer than 20 football fields placed end-to-end. 2 vessels tow this barrier slowly through polluted ocean zones. A submerged skirt reaches 4 meters below the surface, the exact depth where most plastic waste concentrates. The genius is simplicity. As System 003 drifts with ocean currents, wind and water naturally push plastic debris into the U-shaped interior. The current directs everything toward a retention zone at the back. No pumps, no fuel consumption, just physics. Once the retention bag fills with plastic, it's hoisted onto the support vessel, where waste is sorted and shipped to shore for processing. Then the system redeploys for another cycle. What makes System 003 revolutionary is AI-powered navigation. The system analyzes real-time ocean current data, satellite imagery, and plastic density maps to steer toward the highest concentration zones, maximizing collection efficiency with every mission. The system cleans an area equivalent to a football field every few seconds, operating 24/7 without fossil fuels, powered only by ocean drift and solar energy. By mid-2025, System 003 had removed over 30,000 tons of plastic from the Great Pacific Garbage Patch, one of the most polluted areas on Earth. But ocean cleanup is only half the solution. Over 80% of ocean plastic originates from rivers where cities continuously push millions of tons toward the sea. The interceptor, stopping plastic at the source. Instead of waiting for plastic to reach the ocean, American engineers deployed interceptors, autonomous solar-powered systems positioned on rivers worldwide. The interceptor uses a floating boom to guide trash into an onboard intake. A conveyor belt automatically lifts debris from the water into storage containers capable of holding 50 cubic meters, approximately 1 ton of plastic daily. These systems run continuously day and night without disrupting boat traffic or harming aquatic life. They're the first line of defense, catching plastic before it ever reaches the sea. Once collected, whether from ocean-based System 003 or river-based interceptors, specialized skimmer vessels transport the waste to shore. These boats, typically 25 to 30 feet long, can collect up to 5 tons in an 8-hour shift. Hydraulic conveyor belts offload debris directly onto docks or into primary sorting facilities. Sorting the ocean's garbage. At the sorting facility, workers first remove hazardous items manually: tangled fishing nets, discarded tires, oil containers, anything that could damage downstream processing equipment. Then the remaining waste enters a massive rotating cylinder called a trommel drum. This machine spins continuously, separating recyclable plastic from sand, seaweed, shells, and organic marine debris through precisely sized perforations. After mechanical separation, workers conduct a second manual inspection, dividing materials into 3 categories: plastic suitable for recycling, primarily PET and HDPE; metals that can be reused, organic matter like driftwood or biodegradable waste. The clean, sorted plastic fraction then moves into the deep cleaning stage, the critical transformation from contaminated ocean trash into industrial-grade feedstock. Deep cleaning, from trash to treasure. What's retrieved from the ocean isn't clean bottles. It's fragmented debris coated with crude oil, algae, salt sludge, and biological residue after months underwater. The cleaning process begins in mechanical washing tanks, where powerful vortex currents generated by industrial paddles strip away layers of contamination through water friction alone. Because plastic has been weakened by long-term ocean exposure, turbulence must be precisely calibrated, strong enough to clean without damaging the material structure. Next comes thermal washing, water heated to 160 to 180 degrees. Fahrenheit softens remaining contaminants, while neutralizing agents remove salt and balance acidity from decomposed organic compounds. Then, density-based separation using the float sink principle. Heavier plastics like PET sink to the bottom, while lighter plastics, HDPE and PP, float to the surface. This physical separation significantly improves downstream recycling quality. After separation comes drying through centrifugal systems using hot air to remove moisture. But moisture isn't the only problem. Ocean plastics carry organic compounds producing fishy, oily, or decaying odors. Ozone deodorization is applied immediately after drying. Ozone's strong oxidation breaks down odor-causing molecules and destroys remaining bacteria. The result: clean, dry, odor-free plastic ready for industrial recycling. Industrial recycling. Precision. At scale, the cleaned plastic enters a second refining stage targeting the highest value materials, PET and HDPE, widely favored for their durability, recyclability, and compliance with food packaging standards. First, industrial magnets remove metallic contaminants, aluminum seals, cap rings, foil fragments. Then, high-speed airstreams remove remaining labels and caps, because labels are often different plastic types that affect purity. Once material reaches acceptable purity, it passes through high-speed grinders where blades rotating at thousands of RPM reduce plastic into uniform flakes. This flake shape isn't random. It increases surface area compared to bulk plastic, reducing energy consumption by 40% during thermal melting. Even after cleaning, grinding, and drying, one challenge remains: microscopic impurities within the same plastic type. Small variations in color or transparency invisible to the naked eye affect final product quality. AI-powered hyperspectral cameras scan each tiny piece, analyzing transparency, reflectivity, and surface color. Upon detecting contaminants, high-speed airstreams immediately remove faulty pieces from the line. With 95% plus accuracy processing 1,000 pieces per second, these systems ensure only the purest material proceeds to final conversion. Transformation into new products. The sorted flakes enter sealed heating chambers at 520 degrees Fahrenheit. Multi-stage vacuum systems remove residual moisture, air bubbles, and contaminants, leaving pure molten plastic with stable viscosity. This molten plastic undergoes underwater pelletizing. High-pressure cold water rapidly cools and shapes it into perfectly round pellets, free of cracks, voids, or trapped gases, meeting global industrial standards. All pellets undergo rigorous quality control, rapid cooling followed by industrial camera inspection, verifying size and clarity, tensile strength testing, and chemical composition analysis. Each production batch receives a QR code enabling full traceability from ocean coordinates to recycling plant origin. Finally comes product formation using injection molding and blow molding technology. Plastic pellets are shaped into bottles, jars, or preforms at thousands of units per second with near zero defects. Where recycled ocean plastic goes. In the electric vehicle industry, recycled ocean plastic manufactures door panels, floor mats, and seat frames for models like KIA EV6 and Volvo EX30, lightweight yet durable, reducing vehicle weight and CO2 emissions. Fashion brands like Adidas and Parley transform ocean plastic into ultrafine polyester yarns, producing sneakers, swimwear, and backpacks. Each pair of shoes containing up to 11 bottles that once floated at sea. Even furniture and construction industries are evolving. Recycled plastic molded into sustainable chairs, tables, and eco-bricks, 30% lighter than conventional concrete while maintaining impressive load-bearing strength. What's revolutionary is transparency. Each product comes with a QR code or blockchain ID. By scanning the code, users trace the item from polluted marine zone to recycling facility to finished product. Conclusion: from ocean floor to production line, American engineers transformed worthless marine debris into premium-grade industrial material powering global manufacturing. This isn't just environmental cleanup. It's economic transformation, creating thousands of green jobs while compelling corporations like Coca-Cola, KIA, and Adidas to shift towards sustainable models. The ocean is cleaning itself, and the plastic that poisoned it is now building the products that power modern life.